Think about the capacity that you really wish you had because you had a more efficient process to drive growth of the business versus throwing labor at it. People throw labor at it all the time, and you're right, Paul. $2 million again. If you're a $100 million company, change is going to be there, and in the high complex manufacturing space, change is going to be there. Whether it's form fit, itchy, let's get the itchy out, right? That's a whole different process, but you can spend a lot of money dealing with it.
Growing a business requires a holistic approach that extends beyond sales and marketing. This approach needs alignment among people, processes, and technologies. So if you're a business owner, operations, or finance leader looking to learn growth strategies from your peers and competitors, you're tuned into the right podcast. Welcome to the WBS Podcast, where scalable growth using business systems is our number one priority. Now, here is your host, Sam Gupta.
Hey everyone, welcome back to another episode of the WBS Podcast. I'm Sam Gupta, your host and principal consultant at independent ERP and digital transformation consulting firm Elevate IQ. What comes to mind when you think of engineering change control? Well, if you are a small shop with a few changes per month or relatively straightforward products, then you might not see as many change orders. But if you are a highly engineered shop or sell custom products, you might receive change orders even after shipping your products. Heavy on change orders? Then you must need a formalized engineering change control process. Otherwise, you might struggle a lot. So, what are the best practices of engineering change control? In today's episode, we invited a panel of cross functional experts for a live interview on LinkedIn who brings significant expertise to discuss engineering change control best practices. We discussed the nuances of engineering change control process for various industries and how form, fit, and function drives the ECM process. Finally, we covered several other concepts related to engineering change control, such as revision number, reference designator, engineering change notices, and how compliance in several regulated industries might drive the engineering change control process. With that, let's get to the conversation. Hello, everyone. Welcome to today's show. And if you're joining for the first time, this is part of our digital transformation for which we meet every Thursday at 5:30 p.m. Eastern. We pick one topic related to digital transformation, and we always have an expert panel here. For today, we are going to be discussing a very deep topic. It's called engineering change control. It could get really complex overall with respect to the requirements, how the data is going to flow from engineering to your ERP. And if you don't have your engineering data in control, obviously you are going to see a lot of downstream issues. On that note, we are going to start with everybody's intros first, and then we are going to do the deep dive into the topic. So I'll start with my intro. If you don't know me, Sam Gupta, principal at Elevate IQ. Elevate IQ is the independent ERP and digital transformation consulting firm. On that note, I am going to move to Chuck for his intro.
Hey, my name's Chuck Hockstead. I started my career running an engineering design department many years ago and have grown from there. I love this topic, 35-year manufacturing professional. Looking forward to it.
Awesome. Thank you so much for being here, Chuck. Nirav, can I ask you to introduce yourself next?
Yeah, absolutely. Nirav Shah, I'm CEO of AdSerious ERP. We're a premier Acumatica partner. Like Chuck, in my career, I've dealt a lot in the manufacturing sector, implemented ERP software, and there was a time where I was selling engineering change management solutions out there for ERPs. And so have a lot of stories, have a lot of good insight to share. Ultimately, right, manufacturing just more than putting things together. It's the ability to go ahead and see the principles, create something out of nothing, right, and be having a perfect product out the door.
Awesome. Thank you so much for being here now. Paul, can I ask you to introduce yourself next?
Sure, quickly. We're process and operations consultants. Our focus is to help manufacturers take the business from there to there in that much time. Doesn't come across visual. Anyway, process and execution, operating and technology implementation for manufacturers.
Awesome. Thank you so much for being here, Paul. So if you're in the audience and joining for the first time, make sure you guys post your questions and comments. We typically try to cover them during the show. If we run out of time, we'll make sure that you guys are going to receive your answers. On that note, I am going to start with the first question with Chuck. And Chuck, this is going to be the overarching view of what is engineering change control. If you could walk us through the process, okay, how the process starts from the beginning, how that flows through the ERP, and what are different terms. And I know we were talking about different ECs in the pre-shows. So if you could touch on those, and then we'll probably ask other people to touch on those as well. So just provide the context overall in terms of the engineering change control process.
Absolutely. So, anybody that thinks that their designs are not going to change, they're silly. The engineering change control process is very simple. It's really important to understand that when a design changes, in theory, it's as if it's a different SKU. Comparison for engineering design is form, fit, and function. Okay.
Yep.
Even if there is a design control and you just change a revision, but the form, fit, and function do not change, it needs consideration. It needs evaluation as whether or not that is a unique product that is suitable to carry forth into your manufacturing process or all the way to your customer. The change control process is an orderly process where someone identifies the need for a change, the formal request, it's reviewed. Okay. That way we may understand that all of the different business processes are covered. Okay. And then once we do that, we can go forward with executing the design change documents and then carry that forward into, for instance, manufacturing, because it can carry all the way through to the final product and to the customer, and even sales documentation. So it's a very orderly process of discovery, identification of issues, execution, and notification and follow through.
Okay, very interesting insights here. And I especially like your bit about form, fit, and function. And you also mentioned that, the change is always going to be there, irrespective of the product or the customer or the industry that you might be working with. So you need
Certainly.
to probably appreciate that change. But when I think of the form, fit, and function, it could mean a lot of different things. I don't think most people really understand how to sort of distinguish between if you think about matrix inventory in your apparel industry, okay, it should be very different. Here, when you look at the form, fit, and function, and I'm pretty sure this is probably coming from very deep engineering organizations, and in that, probably they might use the term form, fit, and function. So if you were to sort of paint the colors around that, how to sort of distinguish between and how to go for different SKUs when you are thinking about form, fit, and function, provide some more commentary there, Chuck.
Absolutely. So yes, it does come from an understanding, and it arises from a mechanical design, electrical design. Form is the product form physically changes. I can illustrate through exaggeration. Okay, I can put a third ear cup on my headphones. That would change the form. Okay, the fit is that I could make them much smaller and they wouldn't fit on this big bald head. Okay, and the function is that they might send the sound outward instead of inward toward my ear. Okay, form, fit, and function. And so, all of these things clearly affect whether, the size. Okay, it'll affect piece parts that go into that. Okay, so you have a supply chain concern. Fit, okay, that can clearly, go into does the part feed another higher level assembly and manufacture. Also, does it function the same or fit the same from the customer? Okay, so, and that really does go beyond mechanical design. It does go beyond electrical design. It even can go all the way to architecture to extend those same.
Okay, love your insights. Thank you so much, Chuck, for that. And before I move to Nirav, Chris, do you want to introduce yourself?
Sure. Chris Giardini, owner and CEO of Turnkey Technologies. We're a 28-year Microsoft partner. So I do a lot of manufacturing, deal with a lot of aerospace stuff. It's a fun topic. And sorry, I dropped the internet there for a bit, but thanks. And I'm back.
No problem. Thank you so much for being here, Chuck. So Nirav, we are going to be building over what Chuck just mentioned in defining the form, fit, and function. So let's say if you were to translate this insight more in terms of the ERP, how different SKUs are going to be for different form, function, how you are going to be structuring the SKUs in different industries. Maybe if you can provide some sort of examples from different industries of how to think about designing these SKUs, designing the revisions about form, fit, and function. That will be super.
Yeah, absolutely, right. And I don't think that's per se a decision. Maybe even what an ERP user would say, right? That has to go as a change potentially. So it goes. There's a notification from the ERP right? Depending on where the request is coming from. Could be not only manufacturing. You're talking about someone doing physical inventory. You're talking about someone receiving in purchase orders. You're talking about someone that receives in, even a return order, essentially, right? That comes in. There should be a way to initiate a request for engineering change from all these different document types, right? That request should go through an approval process. You don't want to inundate your engineering team, the application engineers, to all day long just go ahead and start changing all these designs when they haven't gone through a formal review process. Yeah, we want to take the request because the people closest to the floor have a good understanding of how the product is built, right? What limitations is maybe machine have? You can't get to a specific angle. What limitation does something have where that's not really relayed back up there to the engineering team, right? So you could take that understanding how to take the lower level request through an engineering department, right? A request gets approved, and then that gets sent with the formal request number back to as an XML back to their CAD system, right? The CAD system takes it. Now that goes into a queue to get handed off to a proper application engineer. They make the proper changes, right? Now you're talking about the engineering change order. The change order goes into that application engineer's hand. They make the adjustments that they need to make. They make the revisions, bill of material adjustments. They send that back as an engineering change notice, right? That notice now has to be propagated through the system. So that goes into a staging system and possibly one more even set of approval to make sure, because you want to maybe use up some old components because a BOM has changed, okay? Or you want to obsolete a component, but that you already have production orders on the floor. You can't make immediate changes, right? To an open production order out there. You don't want to do that, right? To do a pull it, because that's going to mess up capacity. That's going to mess up, all the other reports out there, how you're planning the material orders. So you want to carefully introduce that maybe as a new revision, right? On top of the item that's being manufactured. So it's a new bill of material potentially for the same amount that's being manufactured now, and the top level item has a new revision number, revision A, revision B, right? So now you have a formal process that you are allowing anybody in the organization, obviously with some permissions, create a request because they see a concern. You want to take their ideas, right? You see a concern. Now let's have a conversation around which ideas do we want to move forward with, right? Prioritize that. Send the high priority ones to application engineers to work on via XML, right? You don't want to be handling paper, right? You want to try to move this stuff back and forth as can be between multiple systems. Now you bring that back as an engineering change order because now you're ready to commit. Either there's new items being generated because of this engineering change order, or there's changes to the bill of material, there's inventory considerations, and then you got to commit those changes, right? So you make sure that you are staying ahead of the times, taking those requests on hand and making those changes on the manufacturing floor. It's a full process, but there's a lot of communication here. If executed properly, right, through the ERP system, planned out properly, right, it could be a valuable tool that could save you money at the end of the day, minimize your scrap.
Okay, very interesting. And you have some very, very, very interesting layers there. And I want to make sure that listeners are able to follow along. So you mentioned a couple of terms, okay? And I don't know how many people are really going to be clear about these terms, what is going to be a context and when to use what. Sometimes, they are probably going to be all over the place in terms of these terms. So you mentioned the ECO, the change order, that is the first one. And then you have the revision, and then you have the engineering change notice. So maybe provide some more colors and maybe provide the examples of each of those, who is going to be the audience, what is going to be the composition when you are looking at, let's say, engineer change order, who initiates it. So yeah, provide some more commentary there.
Absolutely. And all those terms go down to essentially looking at the process and the traceability, right? The audit trail of this engineering change order. So now we're talking about people, right? We're talking about the personas that are using this different type of engineering change processes out there. So you got the engineering change request. It could be the foreman out there on the manufacturing floor, right? It could be the receiving clerk. It could be the shipping clerk. It could be somebody that has the authority to say, hey, there's a defect in this product and we've noticed it and we see it. I need to put a request in so our engineering team, our team that's responsible to doing the product designs in the system, right, gets notice of this particular issue. So that's a request that comes in. The request could be very loose in terms of associating a picture, putting some comments on angles and dimensions on what needs to be updated and changed. That request goes into a queue. Now you have a manager, right, in your engineering department that interfaces maybe with the CAD system and the ERP system. But within the ERP system, they're looking at all these requests coming in and they're prioritizing it, right? Going through an approval process, essentially. Which ones do we want to execute this week? next week, next month? Which ones we don't want to do all together, but we want to archive it, right? Because you want to create that traceability essentially. Now you have that request, you have that manager going through the process, sending it to the CAD system. The CAD system user, now you have a strict maybe engineering, right? Application engineer that's getting this, queuing all this up. They're not in the ERP, right? All they're charged to do is look at the requests that are coming in, make the proper changes. Now, engineering has their own workflow when you talk about SolidWorks, right? We're not into that right now, but talk about SolidWorks and how that queue hole works and how that approval process works. Now, let's assume now that particular drawing is now ready to be released back into the ERP, right? Now that becomes back into the ERP, but it becomes a notice that's linked back to the change request. So you have that auditability, you have that traceability of how it originated, who worked on it, when did it come back in, and ultimately what records were updated in the system, which items were impacted, right? When was a new revision created? What production orders did this impact? What purchase orders did the new items impact, right? Do we have to maybe go back and tell vendors of a new revision for a product, maybe send a new drawing to the vendor potentially, right? So those are all the different stages and or kind of nomenclatures or kind of additional vocabulary around the engineering change process that will help get the proper people in place to audit and also create that traceability to provide the checks and balances that the engineering team, the application, are pulling their hair out with all 50 different requests because one person's just told them 50 different things to do in one day, but it's kind of going through a formal process that's being checked off and only the right because they impact customer orders, maybe impact purchase orders, high dollar amount, right? It impacts a specific project that's being kind of taken off the ground. So those are all the different type of scenarios you want to take in.
Okay, amazing insights there. Thank you so much, Nirav, for that. So, Paul, I am coming to you, and either you want to touch on any of the comments that have been offered so far, but I don't want to overwhelm you with my questions. You have a story that you wanted to share as well as the idea. So, why don't you go ahead and share that story?
So it touches on all of the things that have been said, but really starts. So the case that I want to talk about here is actually a really complex aerospace defense product that has electronics and mechanical, hydraulic, software. It's basically a camera, that reconnaissance camera you bolt onto an F-16 and go flying around. And that raises a whole set of issues that you need to think about in terms of what is it that you actually need to control. So Nirav has talked, very well about the mechanics of how that control is going to get executed. The expansion I'd like to make is you have to think about first, especially in these really complex environments, what is it that you need to change and how do you manage through changes that are occurring not in one function, but multiple functions. It's not just a change on a part, multiple areas where interrelated changes. And one of the things, so in this particular instance, we started with that firm with an engineering project management system that required, if you wanted to see what was happening, you had to know who worked on that project, what computer they used, and make sure that still had the right hard drive in it. So, Chuck, you're laughing because you've been there. Now we've all been there. So, so we first had to rethink what is the process here, and then in those complicated situations, you have RFPs and design, proposal, acceptance, and you go all the way through stages. And one of the important concepts as part of that is baselines at various points. What's the baseline for the RFP? How did we match the requirements in the RFP to what we plan to do there, and what does that baseline look like? And then there's negotiation back and forth with the customer, and you're creating a succession of baselines that actually goes all the way out into this is equipment that's out in service, and they had in fact a unique issue that their equipment will go out and it'll be out there for 40 years. So you really need to think through what your long-term data and retention strategy and how you're going to manage that through all of these changes which are occurring in the field and now with additive manufacturing, you don't have the control of we had the part and we shipped it to them. They can make whatever part they want. Adds another dimension to engineering changes, the provision of parts and the related controls that you need to be able to know what is the product, how was it designed, what was the production, what was the as built configuration, what's the as serviced configuration in life, and then think through that and how all of those various parties are going to play together, if you will, in and I will say obviously in some software, because if you try to do this manually, you're you, Houston, we got a problem. So it is, and having said that, that was a very complex system, and I would say the important part of that is really think through what do you really need in your business to establish the right level of controls, whether that be design, product, service, and then look at how you can effectively automate and integrate all those.
Yeah, so some very interesting insights here. By the way, yeah, Houston is not the only one that is going to have a problem. I think we are going to have problems everywhere if they are not using the system. So good insight there. I can touch on so many different things in your insights, to be honest, but I would like to go back to your story, and if you could touch a little bit more on the traceability aspects of which computers were used, is what you said, and then you had to maintain the hard drive usage as well. So how did you sort of ensure that compliance, and was this part of your ECN process to be able to do that? And I don't know how you did it. Do you want to
Yeah.
touch some
Well, the
more
first
and maybe provide the
so the
industry and the product insights as well? Yeah.
so the first step was to completely revamp their engineering project management system,
Okay.
so that we essentially created, instead of documents everywhere and go and search for every product, we essentially created a front end, a document, but that was the front end to the project that led you to all of the different pieces that were part of that project. So it was it sat up here and pointed you to all of the places that you wanted to look at. And what we also did is, in 30 days, we moved 35,000 documents to a document repository with a structured directories for projects, so that you no longer had to know all of those pieces. Now we had all of that in a document repository, and now you could know, okay, this is where everything is, and now you have a basis to take that next technology step to automate some of the back and forth. In fact, the repository provided a lot of those capabilities, approval paths, and things like that. So that's how we got from chaos to a manageable system that worked for them.
Okay, amazing insight there. Thank you so much, Paul, for that. So, Chris, even if you are going last, I think you are going to show us today, how to steal the show, right? Uh, but then,
All right.
but then, you are also going to be talking about different systems and the integration. And the reason why I am really interested in that is because when we were discussing this in the pre-show, we were discussing a lot of different and what those
Mm-hmm.
ECs are going to be. They are going to be part
Mm-hmm.
of your workflow. They are going to have a lot of different statuses, and when you are going to have multiple systems in your architecture, good luck with that when you are going to have that complex workflow. So maybe talk about
Sure.
the challenges that you're going to get from different system perspective and the whole change control process.
Absolutely. And I mean, just from overall, you hear all the buzzwords: ECM, ECC, ECR, ECN, ECO, ECV, ECP, ECI. There's a lot of them. What are all those ECs? Everything's engineering change. But if you think about the first one, engineering change management, and you think about the governance overarching the process, process. What does engineering change management embody? It's a lot in there. The first thing I'll say is not all systems have an ECM, an engineering change management component. And not all systems have it to the degree that's needed to minimize manual work. So one of the things is we discuss this, which you'll find in the less capable systems. There's a lot of manual process, and depending on your industry and your level of complexity in your manufacturing, that can define the difference between profitability and competitive advantage. Quite frankly. So, as you think about business process, and I think Nirav had a great point. Is hey, how do we create an ECM? How do we get a or an ECR, an engineering change request? Right? How does this thing start? It starts with a request. Hey, we need to make a change. And I think as you look at sophistication of systems, and I have one group that does tons of field service, and they're a manufacturer. And what needs to happen is field service, where they're doing repairs and they're doing remediation. They said, hey, we need to get that to engineering so they fix this problem so we're not fixing it every time. So they're treating the symptoms, not the cause. There's a perfect example of having a service organization that's out there repairing equipment to be able to surface, and they're tracking what was the initial diagnosis, what was the final diagnosis, what's the defect, and to surface service data. And again, to feed it back into engineering change management as a form of a change request, and hopefully it gets through the process where there's a change proposal. How do we do this change? And then then it goes through workflow and is approved. And once it's a proposal and it's accepted, it's going to move into a change order where now it's going to be enacted, right? It's impacting a lot of different things. But so there's one example of how does a complex service system for field service on equipment feed an engineering change request? What else? Quality. Internally, we're doing manufacturing, doing quality. Hey guys, we're failing, we're failing, we're failing. Whoop, feedback loop. And if you didn't know, every engineer has a big block, inputs, outputs, and there's a loop that goes back and it's feedback. So we optimize that stream. So again, as you go through the process, and I deal with a lot of aerospace defense contractors, and back to complexity. Again, if you're simple, maybe fully automated, it doesn't kill you. But if you're aerospace and your complexity, and we're running big SolidWorks and we're running big ERP, and if we don't have the correct level of integration, we have a lot of manual process. And again, where does the request originate? Let's not worry about it. Maybe it's something, this part, the vendor said, hey, guess what? New part. A part change is an engineering change. Okay, a new part, a revision on a part from a vendor is a change. And so again, as you incorporate that into the system, request, the proposal, impact, engineering change impact. Wow. What's the impact of this? Wow. How many bill of materials consume this component, right? The impact may be broad. And then, even impact. What do we have on order? What do we have in production? What are the states of all that? And if you think about a manual process to analyze and aggregate and really come up with an answer on what's the impact, the engineering change impact could be dramatic. And I think as you go back to the systems and the capabilities, we don't create new bombs, we create bomb revisions. Absolutely. We have revisions, revision 1, 2, 3. Again, components in, components out. And again, I think that integration comment that is in the aerospace, I've got a great partner that really built a SolidWorks CAD integration specifically for Dynamics 65 F&O, which means it's so invasive. But to that point, whether I change on the CAD side or I change on the ERP side, we're not replicating work. We're moving documents at the speed of light. The documents are always the latest revision, no matter where I'm doing my work. But moreover, that propagation identification of open POs that I can go in and update, and I can make those changes there. Tracking the POs that are too late, production orders I can impact, production orders it's too late, where, hey, you know what? Are they out the door? Are they finished? Is there a point to bring them back, recycle them, and update them versus tracking customers that have Rev 1? And you know what? We need to get them Rev 2. It's almost like a vehicle and you get a recall. That's exactly engineering change management as an example in your vehicle and a recall. It's a process. It goes through all that. And now all of a sudden they're dealing with impact. So again, this integration capability, and I heard an XML file. Well, that's not the degree of integration. Sure, it'll create the bomb and a new bomb, but again, in the more complex worlds, you can't afford to not have full automation because I've walked in where they've got a CAD and we're not going to integrate them. We're not going to use a different tool, but the manual overhead, and they don't measure the cost of that. And again, if you're a competitive organization, you really need to rationalize the impact of engineering management, manual processes on your organization because the speed of doing business, right? Time is of the essence when you guys identify a problem and you're like, okay, how do we track it? But again, process, we got to run through the process, engineering, approvals, workflow, proposals. Okay, now we're impacting and enacting the change. There's an ECV, that's variance, right? Hey, we thought it would be this. Wow, that change takes a lot more. So now does the proposal match? So even variance, the impact of this change. So again, a lot surrounding ECM processes. And again, not all systems have it. And to your point, Sam, if I'm using an external system for engineering change management, we're manually, and again, to build integrations from an engineering change management to talk to your CAD, talk to your ERP, talk to your bombs, open POs, open production orders, you get a feel for the complexity. It really does challenge an organization. I think that, documentation, How do we really get a clear view of impact? That's difficult unless you're really, really integrated. So, again, by industry, I think you're going to pick different systems. You're looking for an engineering change management module. Is there quality in there? Is there service in there where you can get feeders from those on how do I continue to improve my manufacturing and do less service? I don't want to be fixing stuff, right? And that's what it's all about. So, anyway, those are just some general comments. Hopefully that.
And just to amplify that a little bit, the the cost of not doing that is enormous. We took almost $2 million out of the cost in that case that I mentioned before. Documented real live costs that went away, and we reduced the engineering. I mean, lack of engineering change process generates engineering change because
And these are indirect expenses, and a lot of organizations do a terrible job of managing indirect expense. Oh, the guy's already on the payroll. I don't know how much his
Hmm.
time is spent fixing stuff, cleaning up stuff, updating stuff, but think about the capacity that you really wish you had because you had a more efficient process to drive growth of the business versus throwing labor at it. People throw labor at it all the time, and you're right, Paul. $2 million again. If you're $100 million company, change is going to be there, and in the high complex manufacturing space, change is going to be there. Whether it's form fit, oh, itchy, let's get the itchy out, right? That's a whole different process, but you can spend a lot of money dealing with. Great comment.
Awesome insights, guys. So, Chuck, I'm actually coming back to you. And the things that we want to discuss is going to be there are two layers that everybody sort of spoke, and that is going to be product and service. So, I think service, a lot of people touch that, if service is sort of driving the change request, then we are going to get that change request in our system. So, that's number one, right? And then everybody's sort of talking about product management. But a lot of organizations, when you think about them, they don't necessarily have a product. Okay. And I don't know if there is a fine line between when you are going to formalize your product structure. I know a lot of companies, for example, let's say if you go to any of the sign manufacturing, print manufacturing, they don't even understand what a product is. For them, it is going to be an order, and they are sort of trying to start the process. We have had a lot of conversations. They are like, okay, you are showing me ERP, you are talking about all this product. What the hell is product? We don't understand that. Okay. So when do you sort of formalize the process of product management? Because your engineering change control process is going to be driven by that. If you don't even have a product, then how are you going to have your control process? So Chuck, over to you.
Well, interestingly enough, I mean, the sign manufacturing that you brought up, there is an opportunity for engineering change control.
Yeah.
It's not a bill of material in a sense, right? It's not a drawing in a sense, but depending on the printing process that they use, they may be using a print plate. Okay,
Yeah.
and if there's a change to the customer requirement, they might need to change that print plate. And so, an engineering change control process for the print plate is warranted. The print plate is equivalent to a tool. Okay, but I love that we talk about, we don't have the product management process. We don't have a product. The interesting bit to me is that when these, especially smaller, less mature organizations get started, they don't begin with the end in mind. All I need to do is build something. All I need is something once. Let me get something out the door and everything will be fine. Okay. And that just assumes that everything's going to be rosy and is never going to ever be an issue. When you get to the, if it's something that's serviceable, that was mentioned here. It's like, you feed Chris said, you feed that back to engineering for design changes. Okay. But as Paul mentioned, sometimes you have to do an as built, right? You're documenting something out there that's specific to a customer. Okay. That doesn't necessarily come back to the design. These things happen. So the product management process has to happen at the beginning of your design focus. It's like so many things. It's begin with the end and it doesn't necessarily mean that everything is a product in a sense, right? So we're not talking about a lot of engineering change for services. Okay, so everything else, you have a product or you have a service. It could be a house or it could be a widget. So that has to begin from inception. You going back to the SolidWorks and the design, those systems are amazing. They're meant to save a tremendous amount of time, but in a simple implementation, they're designed they can really just screw everything up. You change a model, you change a solid model once, it flows to all the other documentation. If nobody else knows that got changed, boom, all of a sudden it doesn't fit anymore. Okay. Or it's purple instead of red. And that's just a big problem. So that kind of control, again, begin with the end in mind. How are we going to do that? And that is product management and engineering control change is just a subset of that. It starts with, what is the vision from the customer, or this, or what's saleable in a market or serviceable in a market, okay, and works all the way backwards. But if we don't start product data management from day one, we're in trouble, man.
There's also a cultural issue there. I think everybody on the call knows about the guys who manufacture, who do their work off the drawing that they have stapled on the back of their cork board. And you can do all the engineering change management you want, but in the end, they're going to make it according to that drawing they have stapled on the cork board. So there is a cultural issue that needs to be addressed as well in making sure that this idea that we have a controlled system and we need to build according to what we have designed and developed, that just needs to be part of the culture of the organization as well.
Well, with everything, change is easy if we don't have employees or customers. It's a breeze.
Yeah, so very interesting insights there, guys. Thank you so much. So, Nirav, I'm actually coming to you, and there are some very interesting layers overall in this discussion, especially when Chuck is talking about disconnecting from your engineering process. I think Paul touched on that as well. So, if you are not going to have that control, meaning, for example, one of the things that a lot of ERP systems don't have is going to be tracking of the revision number at the product level. So you are going to have the revision number at the BOM level, but if you don't have that, then you are probably going to have a little problem there. And today I was discussing with one guy that, you know what, they want those revision numbers at the bill level as well, so that you have the complete traceability, but not a lot of ERP systems can support that. And then you have the disconnect between your physical and digital process, as Paul was trying to mention. So, they need to be aligned as well. So, Nirav, over to you. Do you have any thoughts about this one?
Yeah, I mean that's a scary situation because the component lines could have unique different revision levels, right? The bill of material could have unique revision itself, and the item needs to have a different revision. It all has to stay connected, interconnected, right? You can't have an item just be a generic item, but now all of a sudden the BOM keeps changing, right? And like Chuck, going back to Chuck's point, form, function, fit. If it is different, it's really not the same item. It's a different item. You don't want someone picking the different item when they're shipping, right? You don't want someone picking the wrong item when they're going to go ahead and issuing that particular item to the floor, right? To work in process. So yeah, I would say, yeah, I think in that type of system, I think run as far as you can the other way, right? If engineering is important, which Chuck hit the nail right on the head, right? You should keep the end in mind, right? How are you going to keep your data organized? The last thing you want to do is confuse the engineers on what type of item they're actually working on, right? Going back to requests, if you don't know the true revision that item is on, what type of request, how is the engineer supposed to know what revision to pick up and redo or modify, right? Essentially, it all comes down to traceability. And what I really like about a formal engineering request process, and I've implemented it so many times over the years, is the ability to see how efficient your engineering team is and how efficient the products are that you're making on the manufacturing floor. Because if you have good reporting, you could have really nice dashboards created that show you, well, we had 50 high priority engineering change requests that came in, we had 25 medium priority, and we had 10 low priority, right? And then connect that to how many got processed, right? At the end of the day, now you have some real nice analytics, or now you can measure how efficient your engineering department is, or how efficient your products are, and how many requests you're getting essentially on a weekly, on a monthly, on a yearly basis, and what type of items are coming through here consistently all the time, right? Is there a vendor that's causing this issue all the time, right? That's not listening to you guys, or is it maybe a specific work center on a floor that's causing this issue, right? Or is it something you put something on a truck and then next thing you know, it's your truck, and the way it's packaged in the truck, it just moves around so much, it's just denting the item all over the place. So you have to keep going back doing engineering change requests, right? So having this data all together on a formalized process, right? Sometimes in the ERP system, it's not there out of the box, right? But you want to be able to think of the end in mind, right? How are you going to save? As engineering is a huge component of your process, right? You need to have a clear clear, responsible kind of process that everyone knows what their responsibilities are to keep costs down, to be effective, and ultimately deliver a good product to customers.
Okay, yeah, so very interesting points there, and I completely agree with you that you need to keep the end in mind. I guess that's what Chuck has been preaching as well. Now let's go a little specific in terms of the overall correlation between the revision number that we have at the BOM level, and then some ERP systems are going to support the revision number at the item level as well. What is the correlation between these two? The revision number that we have at the BOM level and the revision number that we have at the item level. The overarching picture, you are trying to find out, okay, which item is where, and that's why you have the revision number at the item level. But then in production, whatever is going to be at the BOM level is probably going to be used. So number one question, why do we have at two places? Okay, if you really need at the item level, and if we need at two places, what is the correlation between Rav, over to
Yeah,
you?
yeah, because the BOM could change, right? The ultimately the form function fit could be exactly the same, but the bill of materials is different. There's something changing in bill of materials. There's no change in form function fit. The item is exactly the same, right? Maybe they're using a new resin when they're injection molding something, right? Now you have a new BOM number. You don't want them to use the old resin, essentially, but it's the same item number. So the revision number on the item doesn't change, right? What may change ultimately is the cost between the item, right, with the new revision, right? Because the resin on the new item is going to be a little more expensive possibly than the resin on the old item. Cost is going to be different. Now, if you're storing this item in two different revisions, you want to have that visibility. Well, this item is stored at X cost. This other item with another revision, same item with another revision, stored at this cost. So that is really the true kind of what I would say factor around having different BOM numbers, right, with the same maybe item revision essentially, right, or having different item numbers and not having a BOM, right? Not having a revision. Now, there's another thought that I just thought of. Some companies, depending on how many people they have, right, they might just say we're going to change always the top level revision, but we're going to overwrite the default revision time on the bill of materials. So our bill of materials is always going to have the latest and greatest drawing, but our item number that we're producing will have a new each time, right? That comes down to maintenance at the end of the day, right? How many people do you have managing the process? What is the value that you're adding into your process, right? There's a cost benefit. Does the benefit outweigh the cost to maintain those different components at the specific engineering revision level? Or is there not a lot of value because you're talking about maybe pennies, dimes, or maybe dollars, essentially not too expensive. So you just want to go ahead and maintain it at the item level. So it's just not a black and white answer here, but whether you go one direction or not, I think you need you need like someone that's experts in ERP to go ahead and give you that analysis, right? To help you understand, what way you want to maintain, manage, and set your system up to have the greatest engineering success ultimately, right? Because a lot of engineers I've dealt with, they're pure engineers. They don't want to be in your ERP system. They want to just keep doing engineering, right? Now you have to find that fine line, right? Where is this benefit here for them to also manage some of this ERP data?
Okay, thank you so much, Nara, for those insights. So, Paul, I'm coming to you, and I'm going to take this discussion one layer deeper. Okay, and this is going to be so far we have discussed the revision number at the item level. We have discussed the revision number at the BOM level as well. And sometimes there could be a confusion, and because of the limitations in the ERP system, because they might not support the revision as the production order level. So there are three layers actually, okay, in a lot of different ERP systems, especially if you look at the larger one. So you are going to have revision number at the item level. You are going to have revision number at the BOM level. And BOM is going to be your recipe that you are using each time when you are releasing a production order. But there could be changes on the production order itself. That is the change in your job order that could have another revision. Okay, that the ERP systems might have. So now, if you were to talk about the correlation between these three and, in which instances, which one you are going to use, and if the ERP system does not support the revisions for the production order, how are you going to mitigate that situation? Paul, over to you.
Yeah. So we're taking firearms out of the picture here. Again, you need to think about what is the degree of change in your organization, in your products, and if you have a high degree of change, you need to design that system specifically with that in mind. So you may have different controls at different levels, and all of those have to work to get the right product out the door. Again, it comes back to what do you need? Think first. What do you really need in your business with the level of change and the velocity and scope of those changes? What makes what makes the most sense. Some organizations end up with a a design bill of materials and a production bill of materials, and have controls in place to sort that out, so that the engineering group knows what they're doing, the production group knows what they're doing. Not a simple one size fits all answer.
Okay, very interesting. And Paul, when we were doing this thing in the pre-show, and you had a couple of compliance things that you wanted to discuss, and that you had mentioned even as well. Do you want to bring those up? And how they affect the engineering change control? I think that was defense and aerospace industry, if I recall correctly, right?
So one of the things that in this aerospace company, so they needed to be this was an 80-year-old company, heavily siloed, and they needed to get to today, right? And today is a particular there are particular Department of Defense standards for configuration management, and we had to look at those systems. We ended up with a 6 or 7 page itemized list of the things that we needed to have, again, in this complex environment, in order to get to those compliant configuration management. In that kind of business as well, is the level of change that defense organizations go through is really high. Customer changes requirements on a regular basis, and then all of those have to flow down to suppliers if that's part of the change there. So puts a heavy burden again on think through first. What do we need in our environment, and how can we make sure we're compliant with whatever our internal requirement is and whatever our customer.
Okay, amazing insights there, Paul. And I don't know if you're still talking. I think there's a little delay in the video as well as audio. So, Chris, I am coming over to you. And, one of the things I don't think we have touched is going to be a reference designator. And I don't know if that is going to be part of the control process. So, do you want to provide a little commentary there overall with respect to that and how that fits in the control process?
Yeah, I'm not an expert on that, but reference designators and electronics manufacturing. So yeah, I've been through there, and it gets really interesting as you look at the minutia in the bill of material and some of these little bitty attributes that you need at the component level. And I think one thing I would clarify, even in terms of change, it doesn't have to be a component; it could be a process. So an engineering change management could be the way that you actually manufacture. Imagine you're finishing a part. The finish isn't good enough. We have to change the way we finish that. We need a different type of powder coat or heat treat or something like that. So it could be a process change as well. But as you get into reference designators, I've most often seen those in the circuits, electronics manufacturing. But as you look at just the complexities of that, it's a lot to manage. And again, you go back to revisions again. Where's revision detail kept? And I know you were saying, well, why do I need it at the item level if I got it at the BOM level? Well, there's got to be some continuity up, and in a lot of systems, the primitive ones is how do they handle revisions if it doesn't support it? What would they do? Can I rename an item and then copy it back into the same item number? Okay, well, there's the new one, and they start archiving through a copy process. That's primitive. But in the end, if I'm selling these parts out, I got to know what revision went out with the finished good. And I think that's one of the premises. If I'm managing recalls or I'm managing updates to customers, it's imperative that I know what version do they have in the field. It can't be buried down in the bill of material. So I think there's some context at the finished good level in terms of what is the version that went out the door, and it's probably not part of the SKU. Some people do that. Oh, they keep making new items. Well, that's a problem if you have e-com sites and you're trying to integrate. You don't want that SKU to change. So that revision attribute has to be sub, but at the same time in the bill of material, that revision attribute is part of the key so that I can have multiple instances of the BOM and I can go look at the prior version, the prior version, the prior version. Not all systems do that. A lot of them, you archive them. You can only have one archive. So at most, you can keep one of the prior revisions. So again, differentiation between capability. Paul raises a great point. What do you need? What's your industry require? And then we go back to if you're in a controlled industry, what do you need contractually to get ISO to be able to win a contract? Because a lot of times the requirements to win a contract is you've got to support the detailed revision history such that, hey, we had a problem. We need to find everything that has this revision, every customer, every place it was consumed. And that's a big data exercise if you think about that level. Yeah, I wish I can't talk more on references.
No, that's actually awesome. I think that's sufficient detail that probably people need to know. But I'm going to have just one clarifying question for you, overall, in terms of layering in some more details there. And that's going to be, let's say, if you are working on any sort of lot or serial controlled items in defense aerospace, you are going to have that. So number one question is, okay, at what point of time you are going to be assigning which revision number got transferred to your item. Because at the item level, let's say if you're keeping it at the attribute level, then you need to transfer. So does it get assigned when you are going to be receive the inventory? And then finally, okay, you are assigning two things, revision as well as a serial number. So is there going to be any sort of correlation between those two? Chris, any
Well,
commentary there?
yeah. And the revision, if I execute a production order with a bill of material that's got revision 13, and again, where does that finished good get consumed? That attribute is going to be sub in the detail behind that production order that does get consumed to the item. And at the point where that item comes off the production line, we're attaching a serial number. So again, if I pulled up that serial number and drilled in, I'm going to get to the item. I'm going to get to the revision that's attached to that particular serial number, and eventually goes out the door on the sales order. So we're going to have continuity. It may not be, hey, serial number, oh, the revision's way up high. It's not going to be. You see a SKU, oh, there's the serial for that SKU. Oh, there's the revision. And there's a lot more detail below that as you drill through your ERP system to take a look at, well, what particular component? Because we may have a revision at the BOM. We may have a revision down at a component level. So in the complex engineering diagrams, everything's, oh, I got one revision number. No. BOM, subassembly, components.
Yeah.
When did that component get changed? What was the revision on that component? So, and the reference designated down at the component level as well. So again, you're not going to see all this at the top, but at the same time, the continuity is there in the well constructed ERPs.
Well,
But again, as that serial number is attached,
Yeah.
it is all going to be part of that data set that's attached with. Is what you would say.
Let me add another variation,
Sure.
industry variation. If you look at medical industry, when they're looking at a product, and I had this with a client, you need to have the knowledge for every single product, everything that was in place at the point that was
That's right.
shipped.
That's right.
Everything, test procedures, finishes, materials,
So I one up
supply.
you, Paul. We've got guys doing medical devices that are making spinal cord replacement parts. The other group we have, they bring bodies in the back door, so they're dealing with human tissue. Wow. You think about the traceability around tissue, and you're thinking about the minuscule attributes and donor details. So you're right on. There is just a plethora of data that lives behind the scenes. And in the medical space, whether they're hard devices or they're tissue and DNA based stuff, you're correct. That opens up a whole new degree of complexity. And I think aerospace, defense, medical, they certainly have the biggest requirements. Electronics, sure they do. But yeah, great comment, Paul.
Right. Awesome, guys. So the only thing we can take right now is going to be the closing advice. So Chuck, brief closing advice, please. We have 2 minutes, 4 people.
Yeah, your engineering design and documentation, all the revisions and all the different things can very quickly get out of control. You have to beat the drum on the KISS principle. Keep it simple, stupid. If it means changing bombs to agree with the document revision in order to keep it simple, and that works for you, do it. Always chase the KISS principle.
Love it. Thank you so much, Chuck. Nirav, closing advice, please.
Yeah, I'm going to say, we're humans, right? We learn from our mistakes. That's no different than an ERP system. There's no different than, right, engineering people, right? So it's continuous monitoring, it's making sure we understand where the mistakes are happening. Let's get into a situation where there's feedback back to our application engineers. Let's develop better products out the door, get better margins, get better, happier customers.
Love it. Thank you so much, Nirav. Paul, closing advice, please.
Think first. What are the things that will make a difference for your business in terms of prevention of issues and giving you windows to opportunity in getting your product out the door? What kind of automation would really help you? Don't layer on, let's say, just any automation. Think, what's the process? What do we need? Place to start and continue.
Awesome. Thank you so much, Paul, for that. Chris, closing advice, please.
So as you look at your business process requirements at engineering change management, that's it. Envision them, anticipate the level of complexity in your business in future state and current state, and then try to anticipate and rationalize the amount of manual work it would take to propagate a change through your system, and then multiply it and help you rationalize an ROI to put the right tool in place to make.
Awesome, guys. That's it for today. If you joined for the first time, this was part of our digital transformation series for which we meet every Thursday at 5:30 p.m. Eastern. So make sure you guys are going to be here next week. We are going to come back with another topic. On that note, thanks everyone for tuning in.
Thank you all. See you again.
Good night.
Thank you. Have a great evening.
I cannot thank our guests enough for coming on the show, for sharing their knowledge and journey. I always pick up learnings from our guests, and hopefully you learned something new today. If you want to learn more about Paul Weigel, head over to forabetterbusiness.com. It's for a BETTRBUSINESS.com. If you want to learn more about Chris Garadini or Chuck Coxhead, head over to turnkeytech.com. It's turnkeytec.com. If you want to learn more about Nirav Shah, head over to adcirruserp.com. It's adcirruserp.com. Links and more information will also be available in the show notes. If anything in this podcast resonated with you and your business, you might want to check other related episodes, including the interview with Thomas Klima, who shares his insights into the automated testing for ERP. Also, the interview with Ira Sharp, who shares his insights on open automation and why that is important for manufacturers to understand as they increase the Industry 4.0 maturity for their companies. Also, don't forget to subscribe and spread the word among folks with similar backgrounds. If you have any questions or comments about the show, please review and rate us on your favorite podcasting platform or DM me on any social channels. I'll try my best to respond personally and make sure you get help. Thank you, and I hope to catch you on the next episode of the WBS Podcast.
Thank you for listening to another episode of the WBS Podcast. Be sure to subscribe on your favorite podcasting platform so you never miss an episode. For more information on growth strategies for SMBs using ERP and digital transformation, check out our community at WBS.rocks. We'll see you next time.